Hi everyone, this is lesson 13, inequalities. Okay, so we learned some inequality skills and today we're going to talk about how are inequalities applied in real world scenarios. If you know someone who can drive or someone who can vote, or even someone who can ride a ride in an amusement park, you've actually experienced inequalities. So if you've ever seen a sign that says you need to be at least 48 inches to ride this ride, or only people who are 18 and over can vote. Those are actually inequalities. It's not like you have to be exactly 48 inches and then that's it. Anyone taller than that can also ride the ride, or anyone older than that can also vote. I've also seen ones where you can only order off the kids menu if you're 12 and under. Of course, I'm sure some of you have, even if you turn 13. But each one of those is kind of like a restriction, but it's not saying you have to be one specific age or one specific height. So those are some quick examples of inequalities in the real world. We're going to do this opening exercise, and it says that Tarek is trying to save $265.49 to buy a new tablet. Right now, he has $40 and can save $38 per week each week from his allowance. We're going to write and evaluate an expression to represent the amount of money saved after 2 weeks. So right now he has $40. If he saves $38 a week, then 38 times 2 is going to tell us for 2 weeks how much he has, plus that 40 that he started with. So that means after 2 weeks, he'll have that original $40 plus $38 the first week, $38 the second week. So that's 76, and when I add them together, I get 116. Does he have enough? No, definitely not yet. Let's go ahead and try for 3 weeks. Okay, $38 for 3 weeks plus that $40 that he already had. That would be 40 plus 114, and that's only 154. We're looking for 265.49. Based on these whole numbers, we're not going to see exactly that, so let's see what happens as we continue. You can pause this if it's going too fast, but really what we're doing is we're just plugging in the weeks, multiplying by 38, and then adding the $40 that he started with. Okay, still not enough after 4 weeks. After 5 weeks. Okay, how much do we need? 265.49, okay. Okay, 40 plus 228 is 268. Is that enough? Yes, it is. $268 would be enough. Well, I wonder why they want us to keep going. Okay, after 7 weeks, 266, 306 total. Okay, and then after 8 weeks, that's 40 plus 304, so 344. Okay, so he has enough at 6 weeks or more. 6 weeks or more. So let's go ahead and fill in the question on page 103, and then the next question is the one that I kind of want to talk about as to why did they make us keep going if we know that it was 6 weeks. 6 weeks and onward. Well, why is it possible to have more than one solution? So at this point, if you have an adult or someone who's older and you could ask them this, why might Tarek, I'm not really sure how to say his name, but why wouldn't he just say 6 weeks? Why 7 weeks? Why 8 weeks? What I want you to ask is, what might happen if he bought the tablet when this was the balance in his savings account? Why might he wait for 7 weeks or for 8 weeks? What do you think? And if you don't have someone around, what do you think they would say? Why might he wait? When he has enough right here, why might he wait until his balance is 306 or 344? Okay, from my perspective, I would say that he might want to have a little more in savings, okay? He might not want to spend all his money. he might want to save a little more before spending the $265.49. Okay, so that's why it's at least 6 weeks. At least 6 weeks. Okay, so that's just kind of a quick introduction of inequalities in the real world. So he's trying to say, okay, how many weeks do I have to wait? Well, the minimum that he can wait is 6 weeks. If he waits 5 weeks, he won't have enough because his allowance is only $38 a week and he has 40. So 230 is not enough. The 268 is enough. Okay, hopefully that's including tax. And then definitely more than enough at 7 weeks, more than enough at 8 weeks. So the more that he saves, the better he'll probably feel once he actually makes that big purchase. So that's kind of why it can be an inequality. Okay, we're actually going to skip example 1. And then on page 104, we're going to talk about Connor going to the county fair. He has $22.50 in his pocket. Make sure you're marking the text. He bought a hot dog and a drink for $3.75. Well, it doesn't say, it just says a hot dog and a drink. It doesn't tell me how much each one is, but it's telling me together the hot dog and drink is $3.75. Then he wants to spend the rest of his money on ride tickets, which cost $1.25 each. Okay, so there's no question there. That's the scenario. Let's go ahead and look down below to see what the question is. So for part A, it says to write an inequality to represent the total spent, where R is the number of tickets purchased. So they're talking about those ride tickets. So we're going to call that R. Okay, we know that he spent $3.75 on the hot dog and drink. I guess it doesn't really matter what each one costs on their own because he already spent it. Okay? Then he wants to buy ride tickets, which are $1.25 each. And remember, when you hear that each or per or for every, that's a really good clue that your variable goes there because each ticket is being multiplied by 125, each ride ticket. Now, when we did equations, in fact, in pencil, you can write the equal sign here because I want you to see that this is very, very, very similar to writing equations, which we practiced in the previous lessons, 7, 8, 9, 10, 11. So we practiced writing equations. These are inequalities. So the thing that we're going to have to change is that this equal sign is not going to be an equal sign. It's going to be an inequality. And you have to decide right now, do we want it to be less than 2250 or do we want this to be more than 2250? So I'm going to kind of put a question mark there. What do you think goes there? Do we want all that money to be less than 2250 or do we want it to be more than 2250? Hopefully you said less because all he has is 2250. That's all he has with him. So it has to be less than 2250. And then we have to ask ourselves, can it be 2250 or does it have to be less? So we're trying to determine, do we put the equal sign with it or do we leave it as less than? So think to yourself, if you go to the fair with 2250, can you spend exactly 2250 or does it have to be less than 2250? You can spend exactly 2250. So we're going to go ahead and put the equal sign underneath it. So altogether, this means the hot dog and drink plus all the money he spends on the rides has to be less than or equal to the amount of money he came to the fair with. Okay, let's go ahead and try the second one. I kind of want you to do this one on your own. So it says he wants to use this inequality to determine if he can purchase 10 tickets. So you figure out right now, does he have enough? And when I say substitution, it looks like this. All you're doing is plugging in 10 for the rides. Okay, so if he goes on 10 rides or buys 10 ride tickets, will he have enough money? Go ahead and see if he has enough money. Pause it and see how you do. Okay, 375 plus 1250, because 125 times 10 is 1250. Is that less than or equal to 2250? Yes, it is, because it's only $16.25. If that's a true statement, Oops, it would help if I spelled true correctly. Sorry about that. Wanted to skip the U. Okay, so this is a true statement. So the answer is yes, he will have enough. He will have enough money. Okay, now we're going to try to figure out what is the total maximum number of tickets he can buy based on the given information. So now, write the inequality again, the same one that we've been using, and then actually solve it. Figure out what it is. I know that you can do that. So go ahead and copy down the inequality. It's 375 plus 125x. All has to be less than or equal to 2250. It can't go over 2250. Okay, go ahead and solve that just like an equation. Hopefully you wrote a little smaller than I did so we can fit it all in there. Okay, so whatever the ride tickets are, they have to be less than $18.75. So that's because he already spent that money, if you think about it. He already bought the hot dog and drink. So now he has $18.75 left for the ride ticket. So let's see if that goes in evenly. Did you get x is less than or equal to 15? Okay, very good. So he has to have less than or equal to 15 tickets. He can buy 15 tickets. He cannot buy more than that. Okay, our last example, it's a quick problem if you're looking here, but you do have to understand it. The way it's worded can be a little hard to imagine. So I'm going to help you try to imagine this. On a particular airline, checked bags can weigh no more than 50 pounds. No more than. What does that mean if you are no more than 50 pounds? It's not more than that. So it is less than 50 pounds. Now, can you be 50 pounds? No more than 50 pounds. Well, yeah, 50 pounds isn't more than 50 pounds. So it can be 50 pounds. So we're going to say less than or equal to. Okay, now we know that Sally packed 32 pounds of clothes, 5 identical gifts in a suitcase that weigh 8 pounds. And, 5 identical gifts. That's what I'm telling you. The wording on this is kind of tricky. You got to be careful. 5 identical gifts in a suitcase. And the suitcase weighs 8 pounds. The first time I read it, I thought they were saying the gifts weigh 8 pounds, and that was a little confusing to me. They're saying that the suitcase weighs 8 pounds. So the suitcase weighs 8 pounds. And the clothes weigh 32 pounds. And the gifts, we don't know. We don't know what the gifts weigh, but we know that there's 5 of them and they each weigh the same because they're identical. So really, those are the terms that are going to go into our inequality. So we're going to write it like this. 8 plus 32 plus 5x altogether has to be less than or equal to 50. Okay, and now if we solve that, it's really not too bad because we're going to see some like terms there, and that would be 40 plus 5x. So the suitcase and the clothes weigh 40 pounds, so those gifts can't weigh more than, they cannot weigh more than 10 pounds in total, okay, because if everything else weighs 40, the gifts can't weigh more than 10 because 40 plus 10 is 50. Now we want to know each gift. Divide by 5. The gifts have to weigh less than or equal to 2 pounds each. Okay, we took it a step further because it really just wanted to write an inequality, but I think it's good to see. If each gift weighs up to 2 pounds, so no more than 2 pounds, if they all weigh 2 pounds each, that would be 10 pounds plus the 32 pounds for the clothes plus the 8 pounds for the suitcase, and that cannot exceed 50 pounds. Okay, you can do your summary, and that is a wrap on lesson 13.